Welcome to the Hidden Layer. Today, we are diving into one of the biggest, most frustrating problems in all of AI engineering. And we're going to show you how a brilliant idea that's actually 50 years old can fix it for good.
So let's just start with a feeling I know every single one of us has had. You build this powerful AI agent, right? But it has absolutely no long-term memory. It forgets things you told it 2 minutes ago. And when you try to figure out why it made some weird decision, well, good luck. It's a total black box.
In this explainer, we are breaking down a brand new research paper that introduces what I think is a truly game-changing architectural pattern. It's a blueprint for making your AI agents robust, reliable, and, get this, completely transparent.
We're going to show you how this one simple idea can turn that messy, chaotic AI memory into a clean, searchable history. And hey, for all you applied engineers watching, there's a huge bonus. You're going to want to stick around to the end because we're going to reveal how this system makes debugging your agents an absolute dream. Seriously.
Okay, so let's dive into the core problem. The paper gives it a perfect name: context chaos.
You know, the whole game has just completely changed. A couple years ago, everything was about prompt engineering, crafting that one perfect sentence. But now, that's kind of table stakes. The real challenge is context engineering. We're not talking about a single prompt anymore. We're talking about managing the entire world of information the AI operates in, its memory, its tools, its knowledge base, the whole shebang.
And if you don't manage all that context correctly, you run headfirst into this really nasty problem called context rot. This is where the AI's memory just degrades over time. The context becomes this opaque, unverifiable mess, and your agent just gets more and more unreliable.
Now, I know what you're probably thinking. Well, what about frameworks like LangChain or AutoGen? And yeah, they're a great start. But the paper argues they're basically band-aids. They treat memory and retrieval and tools as these separate things you just bolt on. The result? A bunch of temporary, disconnected artifacts. So when you need to figure out why an agent did something, for accountability, it's pretty much impossible.
So, how in the world do we fix this chaos? Well, the paper proposes this really powerful shift in how we think about the problem, and it is beautifully simple.
It all comes down to one single, profound idea, borrowed from the 50-year-old Unix philosophy. Everything is a file. Just imagine that for a second. What if we treated everything the AI interacts with, its memory, its tools, external websites, even our own feedback, as just a simple file in a file system? This idea completely reframes the entire problem. The large language model stops being just a brain in a jar. It becomes the kernel of an operating system. Its job is to orchestrate all its resources, memory, tools, other agents, in a structured, predictable way, just like the OS on your laptop manages your apps and files.
Okay, so this AI as an OS idea sounds awesome in theory, right? But what does it actually look like as a piece of software you can build?
The paper calls the solution the Agentic File System, and it's so clever. It's basically this virtual layer that sits between the AI agent and everything else. All the context sources, memory, tools, databases are mounted into this file system. This means the agent can now talk to a super complex vector database and a simple text file using the exact same basic commands: read, write, and search.
And here's the part that should make every software engineer's heart sing. This approach brings decades of proven, stable software engineering principles into the Wild West of AI development. Suddenly, you get proper abstraction, hiding all the messy details, you get modularity, so you can swap out a database like you're changing a tire, and most importantly, you get traceability. Every single interaction is logged.
This system also creates a super clear lifecycle for information. Raw interactions get written to an unchangeable history log. Nothing can ever alter it. Then, that history gets processed into a structured, retrievable memory. And for just quick, in-the-moment thinking, the agent uses a temporary scratchpad. It's this clean, persistent flow where nothing ever gets lost.
Now, the really crucial insight here is that not all memory is the same, right? A thought you have for 2 seconds is different from a core belief. This file system gets that, so it can manage each type differently. You've got your temporary scratchpad, your episodic memory for what happened in a session, and your long-term fact memory. But the real magic is they all look like simple files to the agent, which talks to them all in the exact same way.
Okay, so we've got the theory down. Let's talk about the real-world payoff. How does this architecture actually help us build better, more reliable agents?
Well, it creates this incredibly reliable three-step pipeline for managing what the AI knows. So, step 1, a constructor intelligently pulls the most important info from the file system and packs it to fit into the model's limited attention span, its token window. Step 2, an updater zaps that context into the AI's active brain. And step 3, an evaluator checks the AI's output and then writes any new important stuff back into the permanent file system. It's a clean, verifiable, beautiful loop.
And here it is, the big payoff we promised you. Because every single action, every piece of memory the agent looks at, every tool it uses is logged as a simple file operation with a timestamp. You get a perfect step-by-step audit trail of the AI's entire thought process. It's all right there.
For an applied engineer, this is an absolute game changer. Think about it. An agent gives you a bizarre answer? No problem. You can reconstruct the exact context it had at that precise moment. You can trace errors back to a single file or operation. You can manage and version your context just like its source code. This solves one of the biggest headaches in production AI today.
And the best part? This is not some academic pipe dream. The authors have already built an open-sourced framework called AIGNE that implements this whole system. You can go and use it right now. It even has connectors for real-world tools like the GitHub API, letting you treat an entire codebase as if it were just another folder on your hard drive.
This whole idea, it represents a really fundamental shift. We're moving beyond just prompting AIs. We're moving toward giving them the tools to build, organize, and even verify their own understanding of the world. And that might just be the next giant leap for artificial intelligence. Thanks for joining us on The Hidden Layer.